All right, so in this lesson, I talked about two different gas laws. The first one is Boyle's law, which tells us P1 times V1 equals P2 times V2. So the value of this equation is that it lets us know that pressure and volume of a gas are inversely related, meaning when pressure increases, volume decreases, or when volume increases, pressure will decrease. The other gas law I talked about was Charles's law, V1 over T1 equals V2 over T2. And this equation looks different from Boyle's law, and it is because volume and temperature of a gas are directly related. When temperature of a gas increases, the volume also increases. So I'm going to have us go through quickly two more practice problems using Boyle's and Charles's law. So for number one, it says I've got a car with an internal volume of 12,000 liters. If I drive my car into a river and it implodes, what will the volume of the gas be when the pressure goes from 1.20 atmospheres to 980 millimeters of mercury? So this is my V1, this is my P1, and this is my P2. Now keep in mind, when I'm using my equation, P1 V1 equals P2 V2, it doesn't matter what the units for pressure and volume are, as long as they are the same on both sides. So right now the pressures are not the same, so I need to convert one of them into the other. So I'm going to convert 980 millimeters of mercury into atmospheres. Okay, so I'm going to put millimeters of mercury on bottom, and I'm going to put atmospheres up top. I know that 1 atmosphere has a pressure of 760 millimeters of mercury, which tells me that my pressure in atmospheres is going to be 1.289, about, and I'm rounding here. So let's plug in my values. My P1 here is 1.20. My V1 is 12,000. Okay. My P2 I just solved for. I got 1.289. And I am solving for my V2. So I am going to divide both sides by my 1.289. Okay. So in my calculator, what I'm going to do is I'm going to take 1.20. I'm going to multiply by 12,000, and then I'm going to divide that by my answer that I got before, my 1.2894, etc., that I had in my calculator. So I'm only rounding once. And what I get unrounded is 11167 let's say 3. Okay, let's figure out sig figs. So right now, 12,000 has 5 sig figs. 1.20 has 3, and this has 3 as well. So I need just 3 sig figs, 1, 2, 3. So this is going to round to 11,200. And my units here, because my units for the other volume were in liters, are going to be in liters. Let's make sure this makes sense. My pressure goes from 1.20 to 1.289. So my pressure increases. So should my volume decrease? Yes, it should. And it did. All right. Let's look at one more example. A gas occupies 900 milliliters at a temperature of 27 degrees Celsius. What is the volume at 132 degrees Celsius? So here, because I am seeing how volume and temperature are related, I'm going to be using Charles's law, while before I used Boyle's law. The one quirky thing about Charles's law, the temperatures must be in Kelvin. So remember to go from Celsius to Kelvin. All you have to do is take your temperature in Celsius and add 273 to it. Okay, so I'm going to do that right here. So my volume is 900 mils. My temperature is 27 degrees Celsius, so I need to add 273 to that. So my temperature is going to be 300, and I'm going to put a point here simply so that I can count each of these digits as significant, because otherwise I would only have 1 sig fig. So it should be 300 point, because I just don't want any decimal places, but I want all 3 of those digits to be significant. I'm solving for my V2. Sorry, I kind of skipped. This is my V1, T1, and this is my T2. So I'm solving for V2 here. I have 132. I need to add 273 to that, so I get 405 for my new temperature. So just looking at this at a glance, I know that the volume I'm going to get is going to be larger since my temperature increased. So let's solve it. So I've got to cross multiply. Okay, and what I have is that 300 times my V2 equals, well, 900 times 405 is 364,500. Okay, I'm going to divide both sides by 300. And what I get for my V2 is 1,215. Let's figure out sig figs quickly. 900 has 1, 2, 3, 4 sig figs. 300, remember I want 3 sig figs for that, 3 sig figs for that. So don't use your temperature in degrees Celsius to determine your sig figs. Once you add 273, the value in Kelvin, that's what you will use for your sig figs. So I want 3 sig figs, 1, 2, 3. So my volume is going to be 1,220. My units, keep in mind my units for volume were in milliliters here, so they need to be in milliliters here as well. All right, so notice my temperature increased, so my volume also increased because according to Charles's law, volume and temperature are directly related.